A fair die is rolled 5 times. Find the probability of obtaining exactly 4 5s. I'm going to use the, what do you call it, the binomial expansion of probability to do this. You don't have to, but in the exam, unless they tell you, you can use any way method you want to. In this one, I am going to use binomial expansion. The first thing I'm going to start off with is I'm going to start to assign values to all my variables. Because we have a dice that rolled 5 times, the number of occurrences, n, will equal 5. Then we're looking at the events. The events say exactly 4 5s are thrown. So we're going to call, we're going to say let R be the number of 5s rolled, and that equals 4 in a row. So let R be the number rolled, and that's going to be 4. What's the probability of getting 1 5? So the probability of getting a 5 is 1 in 6, because the dice got 6 sides. And then Q is the probability of not getting a 5, which means that is 1 take away 1 over 6, and that equals 5 over 6. My probability then to get my probability to find exactly 4 5s, 4 5s will be then the following. It's the combination 5 out of 5, we need 4 4s, multiplied by the probability of finding 6, so 1 in 6 to the power 4, because it happens 4 times. Multiply 1 time, it should not be a 5, so it's exactly 4 5s. For 4 times we have 1 in 6 chances, and then a 5 out of 6. Okay, now you can just use this on your calculator. We know that 5 combination 4 should be 5, and then just everything here will be 1 to the power 4 is 4, times 5 is 5, and then 6 to the power 4 times 6 underneath the bracket will be 6 to the power 5. Do that on your calculator, and your answer should be 25 over 7776, and you can calculate what's the probability there. If I look now at the next one, so I'm going to look at all the results greater than 3. Okay, so again, we have 5 throws, so n is 5. So for B, n is 5. R will now be let R, nasty. I'm going to say n is 5. I'm going to say let R be the number of 5s. I don't have to rewrite that. That's stupid. I'm going to say just all results greater than 5. So R needs to be 5, because it needs to be 5 rows in a row that have 5. What's the probability of getting a value greater than 3? So that is greater than 3 is 4, 5, and 6, which gives you a half. That means that Q is also a half. Okay, so if I've got to calculate the probability of getting 5 numbers 5 times greater than 3, it will be out of 5, I need 5 rows to be greater than 3. The probability of getting a value greater than 3 is a half. So you need to get that 5 times in a row, and then 5 times in a row. Not getting it, 0. That will give me 5 combination 5 is 1, times 1 to the power 5 is 1, 2 to the power 5 is 32, and anything to the power 0 is 1. So my answer is 1 in 32.